Well, a woman that is 1.7 meters tall is walking at a rate of 1.2 meters per second away from a light pole that is 4 meters tall. What? Okay, most of these usually come along with a picture, and so let's just draw our own picture this time. This one seems complicated, but it's really not. So here's a light pole. Looks like a flagpole. But it's shining its light. There it is. Dun, 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 dun. How majestic. And it's blurry, but that's okay. And there is a woman that is 1.7 meters tall. And we'll draw her. So there she is. She's walking, by the way. There she is. Well, apparently she's shuffling and she has really short arms and very long legs, but we'll just go with it, okay? She is 1.7 meters tall, 1.7 meters right there. And she's walking at a rate of 1.2 meters per second away from a light pole. So this distance right here is increasing at a rate of 1.2 meters per second away from a light pole that is 4 meters tall when she is 6 meters from the base of the light pole. So this rate is 1.2 meters per second, but her actual distance is 6 meters. At what rate is the tip of her shadow moving? Like, what? Okay. Oh, there's a lot going on here. So let's continue to draw. The light is shining. And blue light apparently. And this that I'm about to do on the ground right there, let me extend the ground a little bit. There, that is the tip of her shadow. So let's visualize this, and you've probably been in this situation. It's dark, you're walking through a parking lot at night, there's a light shining behind you, and your shadow is moving, right? So you're walking away from a light source, and your shadow is going to be, first of all, getting longer as you get further from the light source. And second of all, the tip of it is going to be moving along the ground. So we're going to figure all this out. So let's start let's start defining some other variables and figuring out some rates of change. And let's just talk about the fact that this rate of change does not change and her height is not changing. Maybe she's growing, but not fast enough for us to deal with in this problem, right? She's growing at a rate of 3 meters per second. She's going crazy. We don't know that. Okay, so I'm going to just call this distance right here x. This one right here, I'm going to call it x because I feel like it. And I'm going to call this one dx dt. And I'm going to call this distance s for shadow. If you don't want to use s because it looks like a 5, that's fine. And then we also have ds dt. And they want to know how fast the tip of her shadow is moving. So that's going to be this right here. So the rate at which this distance is moving is going to be our answer. Actually, this distance is, yeah, we're right. Okay, had to stop and think about it for a second. No, I take it back. We're going to have to fix something. We'll get there in a second. Let's figure this out first, and then we'll actually answer the question, which is going to be a little bit different. I had to stop and think about something for just a second. So we're going to set up an equation, and you're probably like, what equation? Is it Pythagorean? No, we don't know the hypotenuse. Is it trig? No, we don't know the angles. But here's what we do have. We have two similar triangles, and here's one of them. This is the small triangle, which is similar to the big triangle. And so basically, we are going to set up a proportion, and here's our proportion right here. We'll write it in purple, no reason. No, green. You might get to purple later. So little triangle is going to be s divided by 12. Why did I say 12? I don't know. I must have been looking at the wrong thing. 12? Because maybe the girl is 12 years old? I don't know. 1.7. 1.7. So this distance divided by this distance equals this divided by this. Okay, so back in another math class, probably math 2, you learned about similar triangles, and that basically they are triangles that are proportional. And because we have at least two angles that are congruent, the right angle here and this right angle here that would be implied if she was standing up straight, they are congruent. And this angle is used in both the little and the big triangles. We have what's called angle-angle similarity. So little triangle, like s divided by 1.7, is equal to this, which would be s plus x divided by 4. So this over this equals this over this, okay? Let's do this. Let's cross multiply, and when we do that, then we'll take the derivative and we'll have some stuff to deal with, and then we'll actually answer the question, which is not this. That was my thought process just a couple minutes ago. So cross multiplying 4s equals 1.7s plus 1.7x, and we'll get our like terms together. We'll subtract. We'll do 4 minus 1.7. It's going to give me 2.3s, and that is equal to 1.7x. Let's take the derivative. So ds dt on this side, and actually it's 2.3 ds dt equals 1.7 dx dt. And we can start plugging in some numbers. So actually we never ever needed to know what x is or even what s is, and that's okay. So sometimes you just kind of keep going with it and you'll realize, hey, I don't need all that. So 2.3 times ds dt is equal to 1.7 times dx dt, which is positive 1.2 meters per second. And we are going to solve for ds dt by multiplying those two and dividing by 2.3, and we are about to get an answer. And then I need to clarify something. So 1.2 times 1.7. I said one thing and typed something else, but it's going to be accurate. And then there we go. 0.887. And that is going to be meters per second. Okay, is that the speed at which the tip of her shadow is moving? No, it is not. It is not. Okay, that is the speed at which her shadow is increasing in length at that moment. So actually, the speed at which the tip of her shadow is moving is the rate at which the shadow is growing plus the rate at which she walks away. Final answer, which will be in purple, is going to be 1.2. She's walking this fast. Her shadow is growing this fast. And excuse me. And so we are going to have a final answer of 2.087 meters per second.